Hello guys, today we are going to discuss impedance matching and how the transformer can be used for impedance matching. So transformer can be particularly useful when we are trying to ensure the maximum power transfer to the load from the source. So that maximum power is transferred to the load when the impedance is matched with the internal resistance. The impedance is matched to the internal resistance. Even if a perfect match is unattainable, the closer the load, the closer the loader matches to the internal resistance, maximum the power transfer to the load. Unfortunately, unless it is plain as a part of design, most loads are not closed match with the internal impedance of the supply. As we know that the transformer has a unique relationship between their primary and secondary impedances. Therefore, we can use that transformer for impedance matching. So let's start with the first case when we got no transformer here in the first case, and we will see how much power is delivered to the load. So let's start to find the source current for the source current and the total resistance. Here the total resistance is which is almost equal to 30.8 milliampere. So this is a source current, and the power delivered to the load is equal to 30.8 milliampere, which is almost equal to 0.43 watt. Point 15 milliwatt. So let's write the power delivered to the load is 0.43 watt, so which is less than half a watt. So let's discuss the second case, and then we will discuss both the cases at the same time. Now for the case 2, when we put the transformer here, what happened? So as we know this equation, the load impedance and the primary impedance relation, which is this one. Now turn ratio, which is equal to this one. Now put this turn ratio here in this equation, so we will get primary impedance, which is almost equal to 512 ohm. Now we found the primary impedance, which is ohm. Now to find the source current, we will simply use that same formula total resistance. And so the total resistance here is actually which is a primary resistance and the internal resistance, which is equal to 24. So the source resistance here in this case 117.19 milliampere. So let's see the simulation of the first case, then we will proceed next. Now, so this is the first circuit. We put resistance instead of a speaker. So here the current is almost 231 milliampere here in this case, which is almost 231 milliampere. So for the second case, the source current we found is 117.19 milliampere. So according to the formula, P is equal to I square R. So when we put the value of current, which is this one, and our resistance this one, so now which is equal to 7.032 watt. So here we put primary impedance. So the power delivered to the primary, which is equal there to the secondary for the ideal cases. So we put a primary load here. So the power delivered is actually equal to 7.032 watt. So comparing both the levels, what happened when we compare a second case to the first one, which is 0.3 watt. So this is equal to 16.5, which means that the power delivered is 16 times greater to the load because of putting the transformer here in the first case. So when we put the transformer, the power delivery is almost 16 times greater than the first case. Now let's see the simulation of this circuit. So if we look into the simulation, we got a current of 117 milliampere. So here the transformer is used for impedance matching and to increase the maximum power delivered to the load. So this is the end of our lecture. See you in the next video.